Stan Gibilisco here to show you two different configurations for LC circuits, that's inductance L, capacitance C, inductance capacitance circuits that will give you a peaked response or a resonant peak. We call that frequency F sub 0, and we can calculate it using this formula given L in henries and C in farads, or L in microhenries and C in microfarads. I'm not going to try and verbally talk out that equation. It gets a little rough. Can you imagine, the difficulty of speech recognition systems transcribing mathematical texts if they get very complicated? But these circuits both exhibit a response like this: amplitude on the vertical axis, that's signal strength, versus frequency on the horizontal axis, from lower to higher and from zero increasing. And there is a certain frequency at which the response is maximum, F sub 0. This is called a parallel resonant circuit right here, because the capacitance and the inductance appear in parallel, whereas this is called a series resonant circuit, and the reason should be pretty obvious. The capacitance and the inductance appear in series. The same equation holds for both types of circuits. Very simple. The trouble these days is finding an inductor that's suitable for use at radio frequencies. You may actually have to wind your own. You used to be able to get them easily enough at Radio Shack, but then they got harder to find there. You can order them online, or you can wind them yourself and go by trial and error. But these make great audio filters, provided the inductance is high enough. About 100 millihenries is a good value for the inductance, and you can calculate capacitance based on this formula. But in any case, that is the simplest type of peaked response resonant circuit that you can have. It's a passive circuit because it does not amplify anything, and it doesn't use semiconductor components like operational amplifiers or anything like that. It's a straight old-fashioned troglodytical LC circuit, inductance capacitance. They worked in 1940, and they still work today. Stan Gibilisco signing off. Until next time, so long.